Good morning students. Today we are going to see a case study on Newton's law of cooling. So can you tell an example in real life where we can use this Newton's law of cooling using a case study example?
So consider the situation. The time estimate of a person's death is the not most important data for many of the police and detective cases. It is known to all that a dead body started cooling after the circulation of the blood stopped and our body started to lose heat energy from our body. In the early years, many detectives used the mathematical equation of Newton's law of cooling to find the correct time of death, and by the help of this information they solve many cases. By this process we can only estimate the time of the death and our result will not be 100% accurate, but its result will be nearby to the actual death time of a body. Through this case study we want to explain the Newton's law of cooling. The second part has some example and charts for finding the death time, and also we have found the importance of mathematics in the Newton law of cooling.
Okay, good. So she told about the overview of the case study. Now can any one of you introduce what is the case study is going to be?
Yes, ma'am. So let's see the introduction of Newton's law of cooling. Physicist Isaac Newton gave a mathematical equation to find the temperature of an object when it loses heat energy. The heat energy transfers basically from the body of its surrounding. The rate of decreasing or increasing of the temperature of the body is directly proportional to the difference in temperature between the body and the surrounding. Basically, here the formula to find the temperature of the body at a given time is given as below. So let's see that temperature of a body at a specific time, which is equal to surrounding temperature plus starting temperature minus surrounding temperature, which is multiplied into exponential to the power of minus of cooling constant and time.
Okay. So can you tell me the notations used here, ma? What are all the notations used in the case study?
Yes, ma'am. I can tell. Here, the mathematical equation of the above formula T of t is equal to Ts plus T naught minus Ts into exponential power of minus K of t. T of t is equal to temperature of a body at a specific time Kelvin. T is equal to time per second. Ts is equal to temperature of the surrounding area Kelvin. T naught is equal to initial temperature of the body Kelvin. K is equal to cooling constant specific to the object.
Okay, can you tell me a real-time example for this case study, ma?
Yes, ma'am, you can. So, a man shot dead at place Dada in Mumbai at the date of 12 October in 2018. The detective arrives at the scene at around 10:23 p.m. So, immediately the temperature of the body is taken and is found to be 80 degrees Fahrenheit. And then the detective finds that the room temperature has been constant for 68 degrees Fahrenheit. From the crime scene evidence is obtained. Again, the temperature of the body is taken and found to be 78.5 degrees Celsius. So this last temperature reading was taken exactly 1 hour after the first one.
Okay, what formula can be used for this, ma?
By Newton's law of cooling, we have T of t equal to Te plus T naught minus Te into E minus Kt, where T of
T
t
power minus K.
uh, T of t is temperature of the object at the time, and Te is the constant temperature of the environment, and T naught is the initial temperature of the object, and K is the constant that depends on the material properties of the object.
Very good. Okay. How will you solve the problem? Any one of you tell me?
By simplifying and using law of exponents, we get r is equal to 7. Thus, the death time is found to be 7 hours. Therefore, the individual have died 7 hours before the detective has arrived.
Hope you understand this case study on Newton's law of cooling. Okay, let me conclude this. So basically by this experiment, we solve the real life problems with mathematics and science. So we predict the time of death of a body by the help of some informations by using the surrounding temperature and Newton's law of cooling. And there are many equations and formula in physics which are incomplete without mathematics. So mathematics is also an important part of physics, and this Newton's law of cooling is a very important law which is given by Isaac Newton. So thank you all of you for listening.